Okay, for number 4, we're going to estimate solutions this time. So again, you might not know that you have to estimate them in the directions, but it says solve negative x squared plus 4x minus 1 equal to 0 by graphing. If exact roots cannot be found, state the consecutive integers between which the roots are located. And so what that means is we can figure out by the graph and the table where the root is going to happen, and I'll show you how we can do that. First, we're going to graph this. So let's find the vertex. So x equals negative b over 2a, b is equal to 4, a is equal to negative 1, so x equals negative 4 over 2 times negative 1. So that's negative 4 over negative 2, which is positive 2. So x equals 2 is our axis of symmetry as well. Now let's find the y value of the vertex by plugging in 2 into our equation. So remember, we're actually treating this like we're graphing f of x equal to negative x squared plus 4x minus 1 and finding the roots or x-intercepts because it's set equal to 0. Okay, then we have, if we plug in 2, we get negative of 2 squared plus 4 times 2 minus 1. So be careful here because it's negative of 2 squared, so it's a negative of whatever 2 squared is, which we know is 4, so it's negative 4, not positive 4, plus 8 minus 1. And then, so that's 4 minus 1 is 3. So f of 2 is equal to 3. So again, write down your vertex is 2, 3, and our axis of symmetry is x equal to 2. So in our table we're going to do 2 above, 2 below our vertex because that's the center of our parabola. So we're going to do 1, 0, and 3, 4. So f of 0, remember, is just our c value. So that's negative 1. So f of 1 is negative 1, which means f of 3 is negative 1. And then to find, I'm sorry, I did the wrong one. I meant f of 0 here, and then so f of 4 is negative 1. And now we need to do f of 1. That's negative of 1 squared. That's why I always tell you to put it in parentheses. That helps you remember. So that's negative 1 plus 4 minus 1. So that's 2. So f of 1 is equal to 2, which means f of 3 is equal to 2. So there we have our values, and now we can graph that. So graph the axis of symmetry at x equals 2 first. And then we'll graph our vertex, which was 2, 3. And then we had our points 3, 2, and then 4, negative 1. And we had their twin points, which was 2, 2, 1, 2, and 0, negative 1. So, and we expected our parabola to open upside down here. Like that. And now we need to find our x-intercepts. So we can see from our graph that they're not nice. It crosses at a point that I don't know what that is. It's not exact. And another way I can confirm it's not exact is by looking at my table. No points have an exact output of 0. So this means that my roots are not integers. So it doesn't mean that they don't exist. It means that they're not integers. So I'm going to estimate them. So I'm going to estimate them on the graph, and I'm going to say my answers are about, I would say it's closer to 1, 2, 3, 4 here than it is to 3. So I'm going to say 3.75. So x equals 3.75. And then for this one, usually they're going to be, the two roots are going to either add to a whole number or be the same. So like it would either have a 0.75 as well or the complement to make this a whole number. So if anything, if my 3.75 is right, it would be 0.25 on the other one since they're on the same side, it'll be ones that complement each other. That's just a pattern that you'll recognize. So those are my two estimates for the answers to this. And we can actually plug them in and see that they're going to give us a close value to 0. So let's go ahead and do that. Let's plug in. We're going to find f of, and we're not going to write that big. We're going to find f of 3.75. So that we're going to plug it into that original equation here, which was x negative of x squared, so negative 3.75 squared. So 3.75 equals 3 negative of, it was negative x squared, so negative of, not x, 3.75 squared plus 4 times 3.75 minus 1. So you'll just need to grab your calculator to do this. So 3.75 squared is negative, 3.75 squared is positive 14.0625, but it's negative on the outside. Plus, and then 4 times 3.75 is 15, and then minus 1. And then so you can see that these two almost add up to a negative 15, which would zero out that 15. But if we're going to find the exact answer here, negative 14.0625 plus 15 minus 1 is equal to negative 0.0625. So it was close. So I know my estimate is close. It needs to be a little smaller, actually, so that wouldn't be quite as big a negative here. Now we can test the other one. If we do f of, I'm going to put it as 1/4, that's easier. So 0.25. Negative of 1/4 squared plus 4 times 1/4 minus 1. 1/4 squared is 1/16, but it's negative, plus 1. 4 times 1/4 is 1 minus 1. And the 1 minus 1 is 0, so it's negative 1/16, which is the same as negative 0.0625. So you see these are actually twin points because they have the same outputs. So that's again why I said that usually they're complements of each other, add to 1, because they have to be the same distance from the axis of symmetry. So they have the same output. So we're close, which is all we can do right now. And then we could also look in our table that we actually didn't need to estimate that much on this problem. Just realize it said just say the consecutive integers where it's between. So we know that this one was between 3 and 4, closer to 4. This is between 0 and 1, closer to 0. And so that's all we have to say. And we can see that in our table as well. And where we see that in our table is, since this is a continuous graph, we can never lift our pencil, so there's no jumps between values. So if you think about it, if we start at negative 1 and we're increasing to go to 2, positive 2, so we're down here, increase to positive 2, there's no way that you can avoid hitting 0. So the 0 had to happen between that sign change. Same thing over here. We came up to a peak of 3 and came back down to 2, back down to negative 1. So in between these two outputs, there had to be an output of 0, which means in between these two x values, there is a root, an x value that makes the output equal to 0. So for your actual final answer to this one shouldn't have been that specific of an estimate, but we should have said between 3 and 4 and between 0 and 1. So when it asks you just to say the integers, do that. If it asks you to estimate to the nearest thousandth or 100th or something, which we're going to do next, make sure that you do that and follow the directions.